This lesson is about polynomials. Poly means more than one. So we are talking about more than one term. So first let's talk about what are like terms. So can you add and subtract everything you want to? And the answer to that is no. You can only add and subtract like terms. So now the question is, what makes something a like term? So as we look at these terms on the board, we want to see if we can group the like terms together. The way that you can tell something is a like term is if it has the same letters with the same exponents. The numbers in the front can be different, but the letters in the exponents have to be exactly the same. So if we look at this 5x, his like term is the 3x. They are like terms. I could add them or subtract them. If I looked at the 7y, his like term is the 4y. I could add or subtract them together. If I look at the 8xy, his like term is the 5xy. They are like terms because they both have an x and they both have a y. If I look at the 9x squared, his like term would be the 2x squared. Sad little 4 right here doesn't have any like terms because there are no other terms up here that just have a number with no letters. So now that we know what like terms are, we're going to see if we can add and subtract some together. When you add and subtract like terms, you only add and subtract the numbers in the front. You do not touch the x's or the a's or the b's or the powers. You only decide that they are like terms and then you add the numbers in the front. So if I look at number 1, I have 2x plus 5x. Yes, they are like terms because they both have an x. I can add them together, and we know that 2 plus 5 is 7. So that gives me 7x, not 7x squared. Do not add powers when you add your like terms. Again, you are just adding the numbers in the front. So looking at number 2, they are like terms because they both have an a and a b, and the a is squared on both of them. So I can add these together, and a 3 and a negative 7 is going to give me a negative 4. And then the back end stays exactly the same. Number 3, they are not all like terms. If you'll notice, this one has a power of a 3, but this term has a power of a 2, and he has a power of a 2. So while they all have x's, they are not all like terms. This guy right here has no buddies. He has no like terms, so we just bring him down. But then I can combine this one and this one because they are like terms. And please keep in mind that that negative applies to that 4. So that's a negative 4 plus a 7, which is going to give me a positive 3x squared. The back end of the term is kind of like its last name. Last name does not change, just the numbers in the front. So in looking at number 4, I've got terms 4a and a negative 9a. Again, that negative goes to that 9. Those are my like terms. If I add a 4 and a negative 9, that gives me a negative 5a. And then I have a negative 6b and a positive 2b, and that gives me a negative 4b. And the last example we have of this, to find my like terms, I have a positive 5x, I have a negative 3x, and I have a negative 9x. So the 5 and the negative 3 is going to give me a negative 2. And then to combine the negative 2 with the negative 9 will give me a negative 11x. And then I've got a positive 8 and a negative 10, and that gives me a minus 2. Okay, so now I have two polynomials. I have this one which has 3 terms in it, and this one which has 3 terms in it, and I want to add them together. So I'm going to add my like terms. So I have a 5x squared, and there's a number in front of this. It's a 1. You don't have to write it, but if it helps you, you can. So I have a 5x squared and a 1x squared. So that's 6x squared. Then I have this negative 3x and this positive 4x, which are like terms. And so that would give me a positive 1x. And again, you can put the 1 in front of the x, but you don't have to. And then I have this positive 1 and this negative 6, which are like terms, which would give me a negative 5. Also notice how I wrote my answer. It has the x squared term in the front, and then the x to the first power, and then the term that doesn't have an x. That's called descending order, which is how you're going to see most of your answers written. So in looking at number 7, I look at my y squared term, and he has a like term right here. So that'd be 3y squared plus 7y squared, which is 10y squared. And then I have a positive 5y. And if you'll look and look carefully, you'll see that he doesn't have any like terms. So I'm just going to bring him down, positive 5y. And then I have this negative 6 and that negative 9. And when I add those together, that gives me a negative 15. And again, my final answer is in descending order with my second power and then my first power and then my term that doesn't have a y. Okay, these are the ones that are really simple, but students miss these a lot because they don't take the time to change their signs. So with this minus sign in between, this minus applies to everything that's in these parentheses. So what you're going to want to do is change this to a plus sign, and then you change the sign of every term in the parentheses after it, including the first term. So he now becomes a negative. He now becomes a negative, and he is now a positive. And now it's an addition problem just like we had been doing. So we find our like terms. So I have a 5x squared and a negative 1x squared. So that's 4x squared. I have a negative 3x and a negative 4x. So it gives me negative 7x. And I have a 1 and a positive 6, which gives me a positive 7. Same thing on number 9. I'm going to take the time to walk through and change my signs because I don't want to miss this problem. So I'm going to change that to a plus sign, change the 3 to a minus, change this plus to a minus, and change the 5 to a positive. And then I'm going to add my like terms, but you've got to be really careful because this and this are not like terms, and it's really easy to get in the habit of always just adding those first two. But he has a power of a 3, and he has a power of a 2. They're not like terms. This 2x cubed right here has no buddies. He has no other body that has an x cubed term. So we're just going to bring him down. Then I go to my x squared term. That's his like term. So I have a negative 4x squared and a negative 3x squared. So that gives me negative 7x squared. Now, I could move on to this positive 7 here, but if you'll notice in your answer, you have to the third power and to the second power. So think about what term should be next. It should be the x to the first power. So instead of doing this one, I'm going to come over here and do this term next because he is an x to the first. And he has no like term, so I'm just going to bring him down, minus 2x. Then I'm going to add my positive 7 and my positive 5 and get a positive 12. Okay. On number 10, I'm going to change the minus to a plus, change all the signs in the second parentheses, and combine my like terms. So he is like terms with this guy, so that's a 3 and a negative 7, which gives me a negative 4y squared. He has no like terms, so I'm going to bring him down. And then I have a negative 6 and a positive 9, which is a positive 3. Okay, so now we're going to start by multiplying. So this is distributing. This 5 is butted up against these parentheses, which means we need to distribute it. When distributing is multiplying. You do not have to have like terms to be able to multiply. You can multiply anything. You only have to have like terms to be able to add or subtract. So when I distribute, 5 times 2x gives me 10x. And 5 times the negative 9 gives me a negative 45. These are not like terms. I cannot combine them. So that's my final answer. On number 12, I'm going to distribute the 3, but I'm only going to distribute it to the items that are in the parentheses. This minus 2 is just hanging out, waiting for me to finish distributing. So when I distribute my 3, that's going to give me a 12x, and then a minus 21, and then I bring down my minus 2. And a lot of students will walk away from a problem like this, and they're not done. We have like terms that we can combine. Now I don't have any like terms for the 12x, so I'm just going to bring him down. But I can combine the negative 21 and the negative 2 and get a negative 23. Now on number 13, a lot of students look at this and they say, oh, I'm going to distribute the 5. But that 5 is not butted up against those parentheses. That's not what we are distributing. We are distributing this negative. And if you want to put a 1 right there, you can if it helps. But this 5 is just hanging out. And I distribute my negative 1. So negative 1 times 3x gives me a negative 3x. And a negative 1 times a negative 5 gives me a positive 5. Now I want to look and see if I have any like terms. And I do. I have a positive 5 and a positive 5. But if you'll remember, we said we wanted to put our answers in descending order. So I'm going to start with the x term and put him in the front. And you guys know that that negative, it belongs to this 3. So negative 3x. And again, this is a positive 5 and another positive 5. So that gives me a plus 10. On number 14, the only thing that we are distributing is the negative 2. Make sure you take that negative with it. So the 15 is just hanging out. Distribute the negative 2. So negative 2 times 4 gives me a negative 8. A negative 2 times a 3x gives me a negative 6x. And then what is this 5 doing? He's just hanging out. Now that I've done my distributing, now I'm going to combine my like terms, but I'm going to have a heads up and I'm going to look for my descending order. So I really want the negative 6x to go first, and then I'm going to combine my 15 and my negative 8 and my positive 5. So 15 and a negative 8 is going to give me a 7, and 7 plus 5 is going to give me a positive 12. Okay, in number 15, the 8x is just hanging out. I'm distributing not just a 4, but a negative 4. So when I distribute negative 4 to 2x, that gives me a negative 8x. And a negative 4 times a negative 3 is a positive 12. Again, I want to go in descending order, so I'm going to start with my x's. So I have a positive 8x and a negative 8x. They cancel. And all I have left is a 12. So now we're going to try to take a word problem and just write an equation that represents that word problem. So John has $36 in a savings account. He plans on depositing $20 into the account each month and not taking any money out of the account. Write a function rule that will give the total amount he has in the account T after any number of months in. So T represents the total amount he has in the account. So T equals. And then think about it. Okay, so how much money did he start with? He started with $36. So he has a flat $36 sitting in the bank. Now, he's decided that he wants to deposit $20 into the account each month and not take any out. So we are adding to this $36 $20. But not just one time. He said that he wants to deposit $20 into the account each month. And it says after any number of months in. So N represents the number of months. So 20 times N. That way, if it was 2 months, you would just plug a 2 in there. If it was 3 months, you would plug a 3 in there, and that would give you $60, and then you would add it to the $36. If he was going for 4 months, you would plug a 4 in there. 4 times 20 gives you 80, and then you would add the 80 to the 36. So this shows that he is depositing $20 per month, where N represents the number of months. This is how much he had in the bank to start with. So this equation represents how much he has in the bank at any given time. It's got the $36 he started with and then the $20 per month. Suzanne was given $100 for a graduation gift. She also got a job this summer and is babysitting for $15 per hour. Assuming she doesn't spend any of the money, write a function rule that will give the total amount she has, A, after any number of hours, H, babysitting. Okay, A is my total amount, so A equals, and what did she start with? She started with $100. Somebody gave her $100 for graduation. Plus, she is going to add to that $15 per hour, and we don't know how many hours she's going to work. But however many hours that is, it's $15 each time. And we add it together because it adds to her savings. The local cable company in Walnut Cove charges a $120 activation fee for all new accounts. They also charge $45 per month for cable service. Write a function for the charges after any number of months of service. So charges equal, well, they charge you $120 up front just to set it up. Then they're also going to charge you $45 per month. So $120 to set it up plus $45 per month. That equals the total of the charges. Sam earned $3,000 this summer working in his dad's store. His parents are making him pay for his car insurance. He will have to pay $60 each month. Write a function of how much money Sam has, given that he is paying his car insurance each month. Okay, so this one, he earned $3,000 this summer, so he has $3,000. But he has to pay $60 each month. Write a function of how much money he has, M. So money, Sam has $3,000. He earned it this summer working. He has got $3,000. But out of that, he has to pay for his car insurance. So he loses $60 per month. Notice that it's a subtraction sign and not an addition sign. I'm not adding to the money that Sam has. I'm subtracting away from the money that Sam has. Fitness United Gym charges a $100 initiation fee plus $25 per month for membership. Muscles R Us Gym charges $75 initiation fee plus $30 per month for membership. Write a function that represents the difference in the cost between the Fitness United membership and the Muscles R Us membership. So I want the Fitness United minus Muscles R Us. Difference means minus. So I need to set up an equation for Fitness United, and I need to set up an equation for Muscles R Us. So let's see, Fitness United charges a $100 initiation fee plus $25 per month. A $100 initiation fee plus $25 per month. Muscles R Us only charges $75 for your initiation fee, but they're going to charge you $30 per month. So there are my two equations, and it wants me to find the difference. Okay, well, think back to about 15 minutes ago when we talked about this minus in between here. Change it to a plus, and change the sign of everything in the parentheses that follows it. And now I add my like terms. Well, I have 100, and I have a negative 75, and I have a positive 25m, and a negative 30m. And then some of you may be saying, well, that's not in the right order. We put the m first. So if you're going to do that, then the negative has to go with it because that negative belongs to that 5. So negative 5m plus 25. Either one of these answers would be fine. Sprint charges $35 per month for cell phone services plus 10 cents per minute for phone calls. Verizon charges $50 per month but only charges 5 cents a minute for phone calls. Write a function that represents the difference. When you get to problems like this, I'd really like to see you circling that word difference. So we're going to do Sprint minus Verizon. So give me an equation for Sprint. Well, they charge $35 per month plus, now be careful with this, don't write 10. This is 10 cents per minute. Minus, Verizon charges $50 per month, but they only charge 5 cents per minute. Again, the decimals are really important right here. Okay, and again, we talked about it with the minus sign. We're going to change it to a plus. Change the sign of both these guys behind it, and then I'm going to add my like terms. So I have a 35 and a negative 50. So it's going to be a negative 15. All right, now be careful here. I have a positive 10 cents and a negative 5 cents. So that's going to give me a positive 5 cents M. And again, if you wanted to put the M in the front, this positive stays with it. So 0.05 M minus 15. Either one of those would be just fine.